Now let's look at the tools we're going to use. In this course, I only introduced 2 tools. One is Stellar, another we use MATLAB. But in the research workshop associated with this, I'm going to introduce another 2 tools. One is ARPCAD. If you want to choose a programming language, I will use UPO. Those tools, they all have their built-in methodology, like rational rows. They use UML, Unified Modeling Language. They have their own tool. Very complicated. And the last piece, I'm going to show you what you're going to see. And in that picture is a Stellar model. I choose that tool because the power to solve all system ODE, yet the ultimate simplicity. And you can only spend 30 minutes, you can learn how to read it. So this have 4 variables. They use the any logical thinking of a fluid and the filter. You always have the pipes and the stock of the fluids. And the material flow in and out from this is called the stock. And then you have the information flow from this, we call it convert, to where you need the information. And that's called the Stellar model. But if you write this model, let's consider one model, this coupled spring mass system. And then you are going to see we built this second order ODE. The second order ODE is changed into first order. And again, you look at the matrix. And we have this called the first order linear system. And all represented by this matrix as the mathematics model. Oh, by the way, the Stellar is a graphic model. It's equivalent to this mathematics model, but they have the nice simulation feature for you to visualize the running result. Well, there's all different when we talk about a methodology. What means methodology? It's just a method to find a solution. The fundamental challenge of mathematics modeling is the complexity. If it's simple, you don't need a model. We need a model because it's too complicated. So what is your strategy to divide and conquer? There's all different strategy. Like we talk about the Google Earth. All you need is zoom in and zoom out. Simple. They also give some kind of different perspective, like a view. You can view the road. You can view the 3D buildings. And you can view only the mountain and the rivers. Look about the strategy, the UML. I talked about a unified modeling language. They use 9 different meta models. That means they have this so-called state machine and the object cooperation model, and this in my office. Use case model, sequence model, those are all called a different view. What you want to consider your software. Are you looking at the source code, or are you looking at the image it put into the computer? They're different models. But if you go for the summer research, I'm going to introduce a simpler one. It's called the object or process methodology. That kind of methodology only deal with the hierarchy in zoom in and zoom out to manage the complexity. Okay. Now here you go. Here is an OPM model. Again, this methodology is ultimately simple, like Stellar. That's the two most favorite tool I have. They only have these boxes. Those we call it object. And this olivers. And those are the process. And object process methodology have the third element. Well, let me see where I have it. No, I don't have it here. We call it states. So you can zoom in. You see this zoom out. This zoom in. You see another process inside. And here you look at those objects. They have the subsystem. The airplane have an engine system, wind system, and the function of wind is elevating. The engine is thrusting, and so on and so forth. Well, if you look at traffic light have all those, this is traffic light. If you wanted to build a model, this is called a state machine model. And you have yellow, green, red. You have those lines called transition. And I can use a tool called the UPPAL, UPPAAL, to simulate the traffic light. By the way, I give you a simple exercise. If you have a crossroad like this, 3 lanes here, 3 lanes here, I simply ask you how many lights you need for a full control, how many states you're going to have. Just find one corner in the busiest street. Tell me this. You are going to be surprised. My hint is that's hundreds of millions. Without a machine, it's very difficult to really understand the complexity. So in my process, I have another term called the conceptual model. That is a stepstone for scaffold ideas. You're going to see I always start from the problem, build this conceptual model. We only deal with the qualitative relationship, not quantitative relationship. So this will help us to put our hands on. Next, look at the process. We are not going to have much time to deal with this detail. I just want to emphasize the 2 loops. And later on, you have a lot of examples we run through this process. The 2 loops, you start from a problem written in English, and you end up with a mathematics solution. In the middle, you have a mathematics model. But before you build the mathematics model, I emphasize this conceptual model to increase the traceability, to give you a stepstone to scaffold ideas. So the first loop is this loop, from the problem to solution. The reverse loop is called answering justification model loop. A stands for answer, J justification loop. So you start from observing what you know from previous system, literature, and then you verify you did the right math, and then you validate your model makes sense and consistent with the known facts. So these 2 models, I'm not going to go in all the detail of the model. I'll let you read it. That's better for you to think. So the whole idea of a process is kind of like a building code. If you try to get a general contract in the residence building, you have to follow these codes, and then we know you really put the pipes and the sewage system before you dump the concrete, cement. you will not be regretted. And you need to follow the right procedure. When you finish the result, in each stage, we check if you're doing right. So that's the purpose of the procedure. In all these small steps, you can read it first, but this memory cannot substitute your experience. You really need your hand-on work in a few projects. Then you realize, oh yes, I should follow this process. Then I won't make that mistake. And that's what you need to learn. So the difference between the conceptual model and the mathematics model is the conceptual model focuses on the qualitative relationship. And the mathematics model, you need to change the English words into mathematics and deal with quantitative measurement, counting, so on and so forth. So we have a lot of time to talk about that. The last thing I want to say is in this process, you look at the reverse loop. We call it answer justification loop. The emphasis is V and V. Validation and verification is the critical process as important as your developing and the design. So in big company, especially in software industry, and the V and the V team is typically separate from the design and development team. Like in FAA, in NASA, especially in Navy, have a lot of those research in the how to separate the two processes. And anyway, to make sure your model is right, you have to test, and test. The verification and the validation, basically you build all the test case to make sure things is right. Okay, finally, we got to conclude this with some references, and this is the start point of our next 12 hours. And the most things important you learn from what you are doing. Thank you. I'll see you next time.